There we go. Okay. So in order to make our first game, we're going to need some script to help us. And we're going to use some of that script to initialize our game, and we're going to use some of that script to actually allow people to play. To do that, we're going to need to introduce JavaScript into our application. And it gets introduced in a bunch of different ways. It's probably the thing that has the most information on the internet on how to do it, which also means it's the language that you will find the most disinformation on the internet. 90% of what you see out there, I swear, is written by 13-year-old kids who copied and pasted a piece of code that once worked from a friend who got it from a friend who got it from a friend, and they have no idea what they're doing or why. So, you will even find examples on some of the key sites that I will send you to for reference material that are just plain straight out of 1995. So you got to take all of that with a little bit of intelligence and go, okay, I'm seeing this 6 different ways. Scott showed me something a little bit different. Maybe we can find some stuff more modern. The core JavaScript language was built by Brendan Eich as a response very quickly in the matter of a couple of weeks to how do we make these web pages interactive. And he had to come up with something that ran in a browser, and at the time that was very, very constrained for memory. It had to be interpreted, and it had to run in a single thread. And some of those things have retained. So the first thing that retained is it's single-threaded. Now that's not going to make a huge difference to begin with, but it does inform some of the architecture. It means only one thing can happen at a time. And the way JavaScript is put together, it's designed that it can run almost anywhere. So when we design and build our JavaScript, there are some parts to it that are going to be a little bit weird and awkward. The other part is being interpreted. There are some really cool advantages that JavaScript has. And a lot of those advantages distill down into things like what are first order variables, which I'll describe later, and the preponderance of being able to flip types from one thing to another at a moment's notice. So when we start talking about how do we get some advantages out of JavaScript, what we really are referring to is advantages to the programmer. It makes it easier to write software at the expense of there isn't a compiler to catch errors for you. So when something goes wrong, it doesn't go wrong until you run it. And it often doesn't go wrong until you actually execute that piece of your script. In other words, it could run just fine, and then you touch some element, click some button, and all of a sudden, boom, it dies. What we want to do is structure our software so it's relatively easy to find those things and fix those things when we come across them. And that's going to involve lots of screen real estate, really, is what it comes down to. You're going to need the editor you're working in. So you've got your VS Code up running there. You're going to need to run a test server in the background. So using Node.js, we're going to run a test server. You're going to need a browser to see the output, and you're going to need a debugger to take a look at it. So that's at least 4 applications that got to be up at the same time. And if you try and maximize them to the full screen or multiple screens, you're going to be alt-tabbing all over the place. Which is why if you take a look at, all of my screens, there are a whole bunch of little tiny windows all over the place. And most people scoff at that to begin with. But it is what you will end up doing, I guarantee it, because it's more efficient. So in order to do this, we're going to need to tie JavaScript into our HTML program. We're going to try and dive through all of that today. Some of the stuff I can go quickly through because, fortunately, you're programming students, and this is not the first programming class you've ever seen. So we all know programs are a sequence of instructions. And in an interpreted language, every instruction gets implemented one line at a time as it gets read. It gets run right away. JavaScript, like most other languages, ends every statement in a semicolon. However, JavaScript more recently has started to adopt a lot of different conventions and functionality to make programmers' lives more efficient. And it seems inconsistent at first, but it will kind of fit in your head, I hope, very quickly. The first thing is recognize that the version of C++ you're doing is probably C++ 2011 or 2017. Now, if it's 2017, that means the language hasn't been updated in the last 5 years. JavaScript gets updated every year. The version of JavaScript we're going to look at is JavaScript from 2021. So every year, JavaScript improves on itself. I bring this up here because every statement ends in a semicolon, except when it's the last statement in a block or the last statement in a file. You can drop all the semicolons. All of that's just efficiency. You don't need to put it, it's obvious, it's supposed to be there. When we start looking at any programming language, it's a collection of keywords. And when you interpret the programming language, you walk through each line, one line at a time. You pull off the keywords. You pull off the variable names. Variable names refer to the chunk of memory. And as soon as you pull those things apart, the keyword tells you what to do with the things and chunks of memory. We've got some common blocks that go into every programming language, every single one of them. Comments, usually shown first. And again, while Hugo's telling you to comment everything, remember that I trained Hugo. So I'm going to tell you to comment why you're doing something. Don't write how you're doing it. Don't paraphrase your code. I can read your code. Okay? If you use descriptive variable names and your code is relatively clear, you don't need to comment how you're doing something in code. All you need to do is put that one comment at the top. I'm doing this here because it creates this. I'm doing this here because I want to, generate that. And then there's a block of code underneath. I have a certain format and style that I will lay it out. And there's a very, very logical, explicit way that I do it. I don't expect you to 100% follow my coding style. Every programmer does it slightly differently. What I do ask you to do is be consistent. So if you're going to put the curly bracket in a specific location relative to some function or block header, put it in that place everywhere. So just be consistent. White space, be consistent. Don't have one space here and 3 spaces there, and 1 space there and 2 spaces here. Just be consistent. When it comes to operators, the operators in JavaScript are very similar to 2 other programming languages, and that's C# and C++. JavaScript has more in common with C++ than any other programming language. The only reason it's named JavaScript is for marketing purposes. It has very little to do with Java. The keywords in JavaScript are fairly minimal. There's about 30 of them. And you can't use them for anything. Everything in JavaScript is case sensitive. So you can use mixed cased words, and camel case is kind of the norm for a lot of JavaScript. When it comes to flow control, if, then, else, while, do, looping structures, we have all the same normal kind of looping structures and conditional structures that you have in most modern programming languages, and I'll flip through them pretty quickly. The other thing in JavaScript that usually messes people up is that JavaScript has types, but those types are behind the scenes, and you never have to declare them. So when you declare variables with JavaScript, you declare their scope and then the name of the variable, and you just use it. JavaScript's smart enough to figure out what kind of thing you're working with. Always. And it has some simple rules to figure it out if it seems in any way ambiguous. So we take advantage of those rules. Now, if you're used to doing C++ or C#, very quickly you might get frustrated with, how come I can't declare an integer? Right? And what I want to encourage you is, in JavaScript, is like, did you really need to tell me it's an integer? because you declared it and then set it value to 3. Not 3.0, not 3.1, 3. In fact, all numbers are just numbers. So when you declare variables in JavaScript, you don't even have to identify what kind of thing they are. The JavaScript interpreter is smart enough to go, oh, you used it as a number. I think I'll call it a number. It's kind of smart that way. And after a while, you get used to it. The other one caution I will give you is, particularly in these first two terms, you're going to have lots of assignments in lots of different programming languages. And that's not usually a problem for most people, with the exception of if you leave things to the last minute and you try and do multiple programming languages in the same night, you will mess it up. And I tell you that from experience, because if I'm playing around in Unity and writing stuff in C# and then flip over to grade or look at some JavaScript that night or set up something for the next day, it's inevitable that I start writing C# inside my JavaScript files. And for some reason, the JavaScript interpreter really just kind of throws a hissy fit at me when I do that. So what I recommend is, in your own brain, in your own schedule, kind of choose a night a week for each language. That way, if you sit down to do your C++ homework on Tuesday night, then your brain gets into C++ mode and that's all you do. And then Wednesday night comes around and you're like, oh, okay, Wednesday night, well, I know I got a class Thursday with Unity or with C#, so I'll do my Wednesday night, will be my C# night. Right? And it will just keep it straighter in your brain. The opposite side of that, part of the reason we show you so many languages between the operating system course and the main programming courses is because the things I have on the page here are really the things we need you to understand, not the syntax of how to do an if statement in C#. Anybody can look that up. Knowing when to choose an if statement, when to choose a specific kind of loop, when to choose some sort of switch mechanism. Those are the kinds of things that are more important to solving problems and using programming languages to get the right things to happen at the right time. Well, let's take a look at a couple of them. Comments, super straightforward. They're the exact same as C, C++, C#. Okay? Single line comments, double slashes, multi-line comments, /*, *//. Variables. Variables in JavaScript is what we call a loosely typed language. And variables are all global unless specified. And variables are also scoped to what we call function unless specified. Now, this is very different from other programming languages. The first part is global variables, people tell you, are always bad. And it's even more obvious in the web while they're bad. It is possible for you to take one web page or site and embed it in another. It is very easy to do. And when you do so, it's also very possible for the parent site to use a variable. And if that variable has the same name as the name in your site, and yours is global, there's a good chance theirs will overwrite yours and yours will cease to work. So we try and avoid global variables at all costs. There are a few instances where we can't avoid it, but for the most part, we're going to find ways to encapsulate all our variables in our own private little space. The other one that's going to mess people up is that variables are all function level scoped unless we specify in JavaScript. And this is not the same as other programming languages. Other programming languages are block level scoped. Right? Now, what I mean by scoped is how visible is this variable? How far can we see it from where it's declared? In programming languages like C#, if you declare a variable inside some curly brackets, those curly brackets define a block, and that variable no longer exists outside that block. That is not the case with JavaScript. Those variables exist all the way out to a function, unless we use a very special keyword to describe them. So my recommendation is get used to using that keyword all the time. When we declare variables in JavaScript, we're not going to give them a type. We're not going to embed the type in their name. We're going to call them what they are. That's what their name will be. And we're going to use a scope keyword to define how visible they are, how far we can see them. And wherever possible, we're going to give them a value, because that value will help the interpreter figure out what kind of space to allocate for it. There are 4 keywords that define the scope of a variable in JavaScript: const, let, var, and this. Now I'm going to come back to this because that's part of our object-oriented programming. Var is traditional. It's ancient. And nobody uses it anymore. So don't use it. It's a dead word. The only reason it still exists and is not completely deprecated is because there's millions and millions of web pages out there that use it. And the whole internet would break if they took it out. Var is global in scope or function level scoped variables. And there's no need to use them because we can use that new keyword let. Let is a keyword which says this variable is block level scoped. And because it's much easier to understand block level scoping, we'll use it pretty much exclusively, with the exception of constants. Constants don't change. And in JavaScript, we often declare variables as constants because the variables we're creating are actually objects. And we don't want the object to change, but the object being constant does not preclude the member attributes inside that object from being changed. So we can declare an object with a bunch of attributes, and we can change the values of the attributes even if we can't change the object itself. So we'll get into those variable scoping rules as we do more of it. To get going, we've got some basic operators, and by now you've seen all of these before, right? Do I need to go into what any of them are? What is percent equals?
Percent equals the last of the division?
Right, absolutely. It's the modulus operator, right? It's like when you were in kindergarten and you said, hey, what's 3 divided by 2? It's 1 with 1 remainder. Modulus is the remainder, right? Now, when do you use modulus typically?
Usually when I want to see if something's odd or even.
You can use it for odd and even for sure. Part of what we do here is game programming, and game programmers use modulus a lot. So let's say I have a counter, and I make my counter count every, say, frame that's going to be displayed. And I want my AI to run every 20th frame. Right? I can use a modulus to figure out if I just have a tick counter that counts every frame, I could make that tick counter very easily roll over, say, every 600 frames, or every 6,000 frames, doesn't matter. And if I use modulus 20 and say, hey, if modulus 20 is 0, then I can run my AI routine. Otherwise, it's not time for AI to run again. So we use modulus all the time, actually, to kind of separate out different parts of our program as we might run them. All right. Now, you guys have done some programming before, so the very first thing we got to get into is we got to get into how and where do we link this up with our HTML. And there's a couple things we need. So in our Visual Studio Code, which you can probably bring up now, I'm going to start up live share, and I'll put the link in the text channel. There you go. So the easiest way to do this is to leave me on Discord with my fancy slides. But to join the live share, which is a read-only version, and then create a second Visual Studio Code copy running with your own code in it. No.
Sorry, my Discord crashed on me.
No worries. Discord does that. Discord does that. Okay. So one of the first things I'm going to do. Did we set up Node with you guys? Yeah. And did you grab the live server? Yeah. So this is the place to start it up. So I bring up a terminal, I start the live server. You can actually close this terminal again. You're actually just closing the window. It's still running in the background, so you don't have to look at it the whole time. Open the terminal. Yeah. Right? So you can create a new one. I'm going to view my existing terminal. And then run your live server. That's going to run that web server in the background on the folder you're in.
Okay, yeah.
Yay.
I created a new file, like a new history code, so blank. Do we want to go to?
Yeah, you can either go to your Minesweeper application, or you can start in a new folder. Starting a new folder is fine. If you start in a new one, you'll have to build an index.html there, and you can cut and paste. I have the design students do this all the time. Create a new little index, just quick and dirty, right? Copy paste new index.html, fill in some stuff. This is my Minesweeper, right? I've got the little grid going on. So, first things first, I have the live server running so that every time I update this file, the browser just updates. And the second thing is, where the heck do we put our JavaScript? Well, our JavaScript goes in a script tag at the very bottom, just before the body tag. Okay. Now, technically speaking, we can write any JavaScript we want inside that script tag. And I'm going to do that for demo purposes. When we do this for real, we're actually going to pull this out in a separate file. And part of that is just logistically, it's a little bit easier. But the other part is I put the scripts at the very bottom before the body tag for a very specific reason. When you're working with the web, the World Wide Web specification says that scripts belong in the head section. And while that's absolutely true, it's great for using third-party scripts or things you pull in from the internet or things that you're 100% sure work, because the head section gets loaded and then the body section gets loaded and rendered. So if the head section has an error in it, the body will never get loaded and rendered. And it will make it challenging for you to fire up the debugger and see why it's not getting loaded, because you can't load the debugger until the page is rendered. If you put your script tag at the bottom for your code only, what happens is all of the HTML and CSS gets loaded and rendered, and then your script runs. Meaning, if your script is complete garbage, at least all the HTML is on the screen and you can load the debugger and find out why. So, sequencing makes it easier if you just put your scripts at the bottom of your HTML page. We're also building what we call single page applications. There will only ever be one HTML page. It'll always be index.html. There are a couple names we'll use for the external files for our scripts, but by convention, it's almost always called index.js to do an external file. I like to put my JavaScript into a separate folder. And I do that so that it's really stupid obvious if anybody goes into one of my applications and sees there's one file and it's called index.html and a folder called scripts. It should be pretty obvious where all the JavaScript is. So it kind of just makes it really intuitive to figure out. Now, how do we know that our script is running? Well, we have to try it out in the debugger. So once that live server is running, what we want to do is we want to go to the web browser and we want to right click on the background and click on inspect. And mine's going to pop in a separate window for a sec, but let me pop it over there. I'm going to put it on the right side. Okay. This is our debugger. This is the Chrome debugger. It's built into your browser. So not only is your browser, pardon me?
How do you open it again?
Right click and go inspect.
Okay, got it.
Or you can hit F12. Okay. It's in the same place in Firefox. The Firefox debugger is different, and the Firefox treats various different CSS styles different. So I recommend using the Chrome one and getting used to it. And part of the reason that we use this debugger rather than the debugger built into Visual Studio Code is that eventually we're going to do both the client and the server side of our web application. Right now we're using the live server, but eventually we're going to drop that live server and write our own server. When we write our own server, we're going to need its own debugger. And for that one, we'll use the Visual Studio Code debugger. So it's going to be really hard to have one program running in the browser and another program running on the server and debug both of them, which means, yes, you will need yet another window. Okay. Screen real estate.
Sounds like I should get a third monitor.
It never hurts. It absolutely never hurts. 2 is kind of the minimum. You can run with a laptop and one monitor, one external, and just kind of use panels on the sides. But yeah, more real estate, better. It's just the bottom line. It's not about speed or performance with the web. It's just about being able to see everything. Now, when you look in this debugger, it has a bunch of tabs across the top. And I've got them really shrunk down or really blown up, so you can't see all of them here. But we're interested in really 2 of them. One is elements. And in the elements, you're going to see the browser's interpretation of your HTML, which in my case, you might see, what do I got here? Do I have a table in there? There I go. See, the browser's added some HTML that I don't have. It's added this tbody tag. So when the browser reads your HTML, it makes some guesses about how your HTML should work. The more accurate you are with your HTML, the less you let the browser guess. Sometimes the browser guesses wrong. On the right-hand side, you see all the styles. Here's our box model with margins, borders, padding, and the actual content. You can see as I highlight this or highlight this, it highlights the actual web page. As I highlight elements, it actually shows you where the divs are. And you can edit this live. So if I go grab something here and I take that table, it shows me the CSS styles, and I can go in here and say, and it will change it. I can move it. You can see my little crappy table here. 0, 1, 2, 3, 4, 5, 6. As I just play with the arrow keys, I can change the scale of it. If I highlight it, I can see where the table is. None of these stick. You have to go write them back in your CSS or in your HTML. But it will show you this gets applied first, then this, then this. Right? So that's the HTML CSS debugging part. For our source code, we're going to click on sources. And in sources, we can click on the files on the left. Now, I don't have any external files loaded. It's just in my index.html. So it loads my index.html. But if we were actually running it, it'll go down to this script tag here. Now, this code injected by live server, we're going to ignore. Our script is going to go here. And in typical debugger fashion, we've got a thing tells us how many errors. That shows up in the console down here. I've got an error in there. On line 76. Should probably go fix that. Wherever that is. What am I missing? I don't know. I'm missing something. I'm going to have to figure that out. The other thing it shows us is the controls on the top line up here. You see that? You can see the top line. Pause, step over, step into, step out of, run to the next breakpoint, or just make one step. We've got a watch area. Sometimes we're going to take variables and we're going to watch them as they move through our program. Breakpoints. Whenever you set a breakpoint in this debugger, you just click on a line number. And when you click on a line number, that sets a breakpoint. And when you set a breakpoint, your code is going to stop execution just before that line executes. So the line you put the breakpoint on hasn't happened yet. And the thing will sit there and wait and show you the state of everything in terms of scope, i.e. all your variables, and call stack, all the functions and methods you've called to get to that point. So we're going to use the debugger to help us fix our programs, okay? There are other ways to debug programs if you don't have a debugger, but the debugger is far more efficient. And one of the things that David and I will do as we grade everything is we're first going to load it up and then bring up the debugger and make sure there's no errors. I would get marks off for having that syntax error. Where is it? Now, looking at the debugger is really hard to do when it's in this little tiny panel attached to my web browser, and I've got it blown up so big so you guys can actually see it. So for the most part, I'm going to pop this debugger out into a separate window. And that way we can look at the debugger and our code at the same time. Let's see. There we go. So we can see the debugger separately. And now we can make it a little bit bigger. So you can see what's going on. Whoa. Fitting into all these small window spaces. There we go. Whoop. So there's our debugger. Now, like I said, I have to solve my unexpected token problem. Probably just there's an extra greater than sign somewhere.